In this video, we will learn how to derive the indirect utility function from the given utility function and the budget constraint of the consumer. The question is, a consumer's utility function is given by utility is a function of two goods x and y, which is equal to x times y, and the budget constraint of the consumer is equal to px times x plus py times y is equal to m. Px is the price of good x, and py is the price of good y, and m is the total income of the consumer. We need to derive the indirect utility function. Okay, so first step is, what we need to do, we need to maximize the given utility function, which is u is equal to x times y, subject to the budget constraint, that is price of x times units of good x plus price of y times units of good y, and it should be equal to the income of the consumer. Okay, so we have the maximization problem first. Okay, first we need to find out the optimal bundle, that means demand function for good x and y, and we know it is given by the tangency condition, that is at a point where marginal rate of substitution between two goods x and y is equal to the ratio of the prices, that is price of x upon price of y. Okay, and we know it graphically also. If this is x and here we have y, given the budget constraint, okay, given this budget constraint, consumer will try to reach to the highest possible indifference curve, and consumer's utility will be maximized when the indifference curve is tangent to the budget line. It occurs at a point where indifference curve and the budget line is tangent to each other. Okay, so MRS is simply a point. MRS is equal to price of x upon price of y, simply means it is a point where indifference curve and budget constraint are tangent to each other. Okay, and what is MRS? It is simply the marginal utility of good x upon marginal utility of good y. Okay, the ratio of the marginal utilities gives us the MRS. It should be equal to price of x upon price of y. Now, what is marginal utility of good x? It is simply the partial derivative of utility function with respect to good x. Similarly, MUY, that's marginal utility of good y, is simply the partial derivative of utility function with respect to good y, and it should be equal to the ratio of the prices, that is price of x upon price of y. This px upon py is the slope of the budget line, and this mux upon my is the slope of the indifference curve. Okay, so derivative of this function with respect to x, so derivative of x is here 1, so we are left with 1 here, and 1 into y is y. Okay, simple thing. Du upon dx means the partial derivative of this function, so derivative of this function will be y. Du upon dy is the partial derivative of this function with respect to y, so we will be left with x. It should be equal to the ratio of the prices, that is price of x upon price of good y. Solving for a here, let us solve it for y here. So our y will be equal to price of x upon price of y. Transposing this, it will get multiplied. Okay, now we plug this result into the budget constraint. Okay, so we have this budget constraint, so in place of y we will write this stuff. So we have price of x times units of good x plus price of y times units of good y. We calculated it as px upon py into x should be equal to the income of the consumer. Here we can do one thing, we can cancel py, so we will get px times x plus px times x should be equal to m. So this is twice px into x is equal to m, or x will be equal to, transposing twice px, it will get divided, so we will get m upon twice px. This is the demand function for good x. We also call it the Marshallian demand function. Okay, now symmetrically we can find out the demand function for good y. What we need to do, we simply plug the value of x in this function here, so our y will be equal to price of x upon price of y, and the value of x which we calculated as m upon twice px. Here this px and px gets cancelled, so y will be equal to m upon twice py. Okay, so first step was to find out the Marshall and demand function for good x and y. Now to calculate the indirect utility function, what will we do? We will plug the value of the optimal value of good x and good y back into the utility function. So our indirect utility function, let's denote it by v. It will be a function of price of good x, price of good y, and income of the consumer. Okay, so indirect utility function is simply found out by substituting the optimal values of good x and y into the utility function. Okay, so in place of x we have this stuff, m upon twice px, and in place of y we have this function, rather m upon twice py. Okay, so our indirect utility function will become m square upon 4 px py. This is the indirect utility function, and it says us that consumer's utility is a function of the prices of good x and good y, and also the function of the income of the consumer. Okay, so this is how do we find out the indirect utility function from the given direct utility function. I hope I make myself clear in this video. Thank you.